Good afternoon, all of you. And in the last class, we was in the concept, I think that is diffraction, right? So just definition I have given. So now we will see the types of diffraction. Yes, right. So see here. Okay, see here is diffraction. First one, what I told, Fraunhofer. Second one, Fresnel. Okay. So first one, Fraunhofer. And second one is Fresnel. So when this Fraunhofer diffraction takes place at narrow slit, takes place at narrow slit, when parallel rays are incident on it. When parallel rays are incident on it. Whereas this Fresnel diffraction takes place when it is also at narrow slit only. Takes place at narrow slit when non-parallel rays are incident on it. Okay, so there are two types of diffraction we can say. First one is Fraunhofer, another one is Fresnel. ठीक है? Now let's see with the diagram. Now here it is a narrow slit. You can see something like this. Something like this. And these are the parallel rays which are incident on this slit. You can see it. Now, how the light will go? Suppose something like this. Something like this. Okay. This is what? Fraunhofer's diffraction. Now, in the Fresnel diffraction, what is the case? If non-parallel rays are there. Non-parallel means what now? Again, you are having same like this only. Narrow slit. Okay. But this time, the incident light is something like this. Non-parallel. Can you see? You see here, this is non-parallel incidence. Yes. Yes. Okay. So, understood now? So this may be something like this, the light getting diffracted due to this. Even if suppose like this, we have incident and we have kept one convex lens, then that is what? Fraunhofer diffraction. Okay, like this source is there and you just keep here one convex lens, that will be what? Fraunhofer diffraction only. Yes or no? Why? Because again that rays will become parallel before incident on the, what you can say, narrow slit. जैसे कि for example, in this only you see Fraunhofer only. I am showing another diagram. See, this is again a slit, fine slit. Okay, and suppose from this point we have incident something like this light. Something like this. Now what I will do, if I am inserting a convex lens, if I have inserted a convex lens, these rays, how it will go? Again, parallel. You can see here. Getting my point? Then this is also Fraunhofer diffraction only. Yes. This is also Fraunhofer diffraction only. So F D. This is also F D. And this is what? Pre D. Okay. Because both are FF only. Yes. Understood? So This is what Fraunhofer diffraction, and that is what Fresnel diffraction. Yes. Okay. Good. Somewhere here like this light I am showing is diffracted. Note down fast. Clear? I will show you this in the lab. Okay. I will make setup also, but college should open. We can do this. Very nice. We will get on the board. Okay, whiteboard. We will keep as a screen. We will arrange the laser light source. That is laser beam. We will incident on a sharp knife edge, or we can say blades also sometimes. So you will get very nice pattern. Okay, so you will get so much fun in the lab. Right. Finished? Shall I go to the next page? Okay. Right. Now, see here. What actually happens in the diffraction pattern? I'm showing one diagram. Okay. So see here. Now this is a narrow slit. Something like this. Okay. And now what happens here? You see the middle one, whatever the band you are getting, it is big and dark also, we can say. Next, other bands will be of less intensity and smaller size also. They will go on decreasing like this. You can see here. Okay. Similarly, here also something like this. Okay. If we will plot the graph, that is intensity versus path difference. We will plot a graph that is intensity versus path difference. Then how it will be? 1 minute you wait. I will show you. This is what intensity which I am taking on y-axis, and this is what path difference which I am taking on the x-axis. central. Okay. See, on this I'm taking intensity I. Okay, and here I'm taking path difference. If you will see the graph is something like this. Try to understand. Understood? See, I'm drawing with free hand. Something like this. Okay. So see, intensity is maximum and then decreasing, then again decreasing, and then again decreasing. You understood? I think so. Yes, no? It is very easy. This graph is clear. Yes, no? Even from this diagram also you will understand how the intensity decreases from the central bright fringe. Okay, clear? Yes. Yes, finish diagram drawing this one. In the diffraction, just keep it in mind. At the middle, you will get big bright spot. Then as you are going either left side or right side of that, the intensity of that bright spot will go on decreasing. That's it. Okay. In interference, you are getting dark and bright, dark, bright, dark, bright. Here, no dark spot, only all bright spots, but of different intensities. Understood? The difference between diffraction and interference. Clear? Yes. After this, I will give you difference table, diffraction and interference. First, note down this past. Everyone finished? Okay, let's go to the next page. And now, diffraction at single slit. Listen carefully this point, very, very important, even for problem solving also. What is the topic? C? Diffraction at single slit. Okay. Diffraction at single slit. So first let's draw the diagram. Here the slit width is small d, and as usual the distance from the slit to the screen is capital D. Okay. Now you see whatever I have shown, this is for bright spot. So diffraction on the screen diffraction pattern on the screen is formed due to superposition of secondary wavelets. Next point, at point O, waves arrive in phase, and therefore this is what? Central bright fringe. Central bright fringe लिखना है ना? As shown in the previous diagram, at point O, you are getting central bright fringe. And now, what about secondary minimas? You see in the interference, you are getting at the center, you are getting bright fringe, then dark, then bright, then dark, then bright, equal widths, है ना? But here, what is the change? Let's see. And after this, I'm going to show or we are going to find the position of secondary minima. Okay. So first of all, note down this because I want some space or little space for diagram as well as explanation also, so that we can find out the position of first minima as well as maxima also. Finished? Okay. Positions of secondary minima. Positions of secondary minima. So again, you see here, this is the slit. Here it is a screen. Okay. This is what the parallel light which we have incident. You can see here. And now these all rays are, or this is meeting at this point, we can say. This is what diffracted beam, hai na? What is this? Diffracted beam. ठीक है? Okay. This one is what? Width, that is small d. And now I'm drawing one normal here, you can see. and let us suppose this angle is theta. This point is point A, this point is point B, and this is N where I have drawn normal. Then this is what? Wavelength. What is this? Wavelength. You know, which one? This is lambda. Okay. And now this is what? The point, central point. And here it is P1. This P1 is what? First secondary minimum. What is P1 is? First secondary minimum. Clear है? Yes. Draw करो, जल्दी draw करो. Yes, finished. Okay. Now, positions of first of all secondary minimum. Positions of secondary minimum. So already I have given heading now. Okay. First point, direct I am writing. Let P1 be the first secondary minimum. P1 is what? First secondary minimum. Then you see here in triangle ABN, in the triangle ABN, sine theta 1, I am taking this angle as a theta 1. So sine theta 1 is equal to AN by AB, which is equal to AN by D, and AN is again lambda by D. So therefore lambda is equal to D sine theta 1. What is lambda is equal to D sine theta 1. Now path difference is equal to n lambda. Okay, path difference is equal to n lambda, and therefore D sine theta n is equal to n lambda, and therefore sine theta n is equal to what? N lambda by D, where n is equal to 1, 2, 3, and so on. This is what? The formula for what? Angle, है ना? Sine theta. Yes. So lambda is equal to D sine theta 1. If you want first, n is equal to 1. Second, 2, 3, and so on. Okay. Clear? This is for minima. What about maxima? We will see in tomorrow's class. secondary positions of secondary maxima. Okay, and after that width of central maximum. Okay, this we will see in tomorrow's class. Okay, just note down this part.